Hello friends, this is Priyanka. Today we are going to solve a problem on hydrostatic forces on surfaces. So in this video we are going to solve a problem about inclined plane surface submerged in liquid. So first I will read what is the given problem. An inclined rectangular sluice gate AB 1.2 meter by 5 meter size as shown in figure is installed to control the discharge of water. The end A is hinged. Determine the force normal to the gate applied at B to open it. So this was the given question. Now let us first observe what is the given diagram. Now if we observe this diagram, here is the free surface of water is given, and what is the angle of inclination of this gate AB to this free surface of water, that we can say theta is equal to 45 degree. Now the height from this free surface of water to the bottom of the gate, that is at this point B, which is equal to 5 meter, is also given, and here this is the length AB which is equal to 1.2 meter is given. And what we have to find out? We have to find out force normal to gate applied at B to open it. That means we will show here the force F2 that is applied normal to gate. So here this is the inclined gate AB. So we have to draw here one perpendicular line to this AB, and we will say this is the force F2 that should be applied at this point B to open the gate. So how to balance this force F2? So if we observe, because of this water, there is the force applied by this water on this gate AB. So first we have to find out what is the total force F1 or the total pressure applied by water on this gate AB. So here is the force F1, and the point of application of this total force is known as the center of pressure P. So here below the center of gravity point we have to show here the point P, and at this point in this downward direction but perpendicular to this gate AB, because this gate AB is inclined, so we have to show in perpendicular direction this force F1 directing in this downward direction. So this is the force F1, that is here. Now if we observe, the hinge at this point A is given. So what is the function of hinge? Because at this point A this gate is moving. So whenever this force F is getting applied in this downward direction, we have to take the moment of this force F1 about point A, and this force F2 is in the upward direction. So which is equal to, in opposite direction we have to write here force moment of this force F2, that is F2 multiplied by this perpendicular distance from this point A. That means we have to first find out this force F1, then we have to also find out this perpendicular distance, that is the distance from this A to P, which is equal to force F2 that we have to find out multiplied by the perpendicular distance, that is this whole distance A to B. So that is given here 1.2 meter. So now we will first find out what is this force F1, and then we will take the moments of these two forces, that is F1 and F2, about this point A, and we will find out the answer. We know that the total force applied by the water on this gate AB, that is equal to rho A G H bar. So what is this H bar? H bar is the distance of the center of gravity from the free surface of water. So we can say here this is the free surface of water, and here is the point G. So we will take here one vertical line up to the surface of water, that is this distance GD, which is equal to H bar. So we have to find out what is the distance dg. Now if we observe this diagram, the vertical distance from this point B to C is given, that is equal to 5 meter. Now from this point G we will make here one construction line. We will take here one horizontal line from this point G on this line BC. So here the point of intersection will be E. So if we observe this GD, which is equal to CE, and which is equal to this BC minus CE, So what is this distance BC? So we know that the distance BC is equal to 5 meter. And what is this distance BE? Now here is the construction of this triangle. So if we observe this triangle GEB, then in this triangle what is the angle of this horizontal line with this inclined line? Now here this is the free surface of water, that is also one horizontal line, and this is also the horizontal line. So these two are the parallel line and this is the common inclined line. So we can say that this angle with this inclined line to this horizontal line is also equal to 45 degree. So if we observe here this triangle GEB, sine of 45 which is equal to BE divided by BG. So what is the distance BG? That is, G is at the center point. So here 1.2 divided by 2, that is equal to 0.6 meter is the distance from this point B to point G. So from this we can find out this BE. So BE is equal to sine of 45, that is 1 by root 2 multiplied by 0.6. So when we put this value, we will get the distance dg, which is equal to this BC, that is 5, minus this BE, that is 0.6 by root 2, which is equal to 4.576 meter. So now this h bar is known. So now we can calculate what is the total force applied by the water on the surface of the gate AB. That is rho G A h bar. So rho is the 1000 for the water, then G 9.81, A that is area 6 meters square, and h bar that is 4.576. So what is the answer? That is, here if we observe 2,69,343 Newton. So this is the answer for the F. Then again we will move for the calculation of H dash. H dash means we are now going to find out where is the center of pressure, that is the point of application of this total force. Now here this total force we will say here F1. So I will say this is the value of F1. Now where is the point of application of this total force F1? That is, it is below the center of gravity point. So we will show here with the help of P. And this force F1 is applied in the perpendicular direction to this inclined line AB. So this is the force F1, and now where is the exact location of this point P? So we will find out the distance from the free surface of water. So here from this point P we will draw here one vertical line, and this is the distance Pn, which is equal to h dash, that we have to find out. So what is the formula to calculate h dash? That is Ig sin square theta by AH bar plus h bar. So what is this Ig? That is the moment of inertia about the axis passing through the center of gravity point. So center of gravity, that is G is used, that's why here the suffix G is there for the center of gravity point. So here is the formula to find out this Ig, because this is the rectangular shape, that is the gate. So here BD cube by 12. So BD cube by 12, that is 5 into 1.2 cube by 12, which is equal to 0.72 meter. And theta, that is known, h bar, that is also getting calculated. So we can calculate this. So what is the answer of h bar? That is 4.589 meter. So this is the value of h bar, that is, this is the vertical distance P to N. Now we know that we have to take the moments for this force F1 and this force F2. Now if we observe about this hinge A that we have to take, so force F2 multiplied by this perpendicular distance AB, that is known, but the force F1 multiplied by this perpendicular distance, that is the distance from A to P, that is unknown, and that we have to find out. So how to find out this distance A to P? So if we observe this diagram, AP is equal to this whole distance, that is AB minus BP. Now if we observe here, this is AP is equal to this AB. AB is known, minus BP. Now this BP, that is this is the bottom point and this is the point of application of the total force, that is this distance is unknown BP. So again, how to find out this distance BP? Again, if we observe this whole distance BO minus this OP, so here BO, that we can easily calculate this distance BO, and this distance OP, this is also the distance. So how, first we will find out what is the distance BO. So from this bottom point, this is the inclined line, this is the angle of inclination, and here this vertical distance, that is also known, that is 5 meter. So if we consider the triangle BCO, then we can easily write sin 45 is equal to BC divided by BO. So BC is known, sin 45 that is also known, so we can easily calculate this BO. So BO is equal to BC by sin 45, which is equal to 5 by 1 by root 2, and which is equal to 7.071 meter. So this is the BO. Then now we will find out what is the OP. So again, for this OP we will consider the triangle OPN. Now if we observe here this H dash that we have already calculated, that is this PN. So in this triangle, if we observe, this sine of 45 is equal to this H dash divided by OP. So H dash is known, sine 45 is known, so we can easily calculate this OP. So OP is equal to H dash by sine of 45, that is equal to 4.589 by 1 by root 2, and which is equal to 6.489 meter. Now we can calculate the distance BP, that is equal to BO minus OP. So BO is 7.071 minus OP, that is 6.489, which is equal to 0.582. So when we get this distance BP, then how to calculate this AP, that is AB minus BP. So what is this AB, that is 1.2 minus this BP, which is equal to 0.618 meter. Now we will take the moments about this hinge A. So there is the force F1 in this downward direction and force F2 is in the upward direction. So how we can say that this force F2 multiplied by this perpendicular distance, that is this distance AB, which is equal to, because why it is equal to and why we are going to take this F1 in opposite direction, because here the two forces is having the opposite direction. That's why, which is equal to F1 multiplied by this AP. So F1 that we have already calculated, AP that is also we have calculated. So here AB known, so AB is 1.2 meter. So only one unknown term, that is F2, and when we calculate this we will get here the answer 1,38,708 Newton, and this is the answer.